These problems, the washer problems, are going to differ from the disc problems because when we slice it up, the slices are going to have a hole in it. So they're still going to be circular cross sections, but they're going to be in the shape of a washer rather than a disc because they're going to have a hole in it. All right? So let's look at the same region that we had before, except now, instead of rotating around the x-axis, I'm going to rotate it around the y-axis. Since I'm rotating around a vertical axis, which way am I going to slice this thing up? Yeah, horizontally. So my slices, well, I'll just show you this. When we take this thing and we rotate it around the y-axis, it's going to look something like this. Something like a bundt cake. You guys know what a bundt cake is, right? Yep. Okay. So it's going to look something like that. It has a hole in it, right? It's not solid. So it doesn't have just one radius, but it's going to actually have two. So when we take this thing and we rotate it around the y-axis, we're going to slice it horizontally. And what I want to do is look at what happens to just one Riemann sum rectangle here. So if we were going to use these rectangles to add up the area, we could do the same thing to create volumes and add up those volumes. So when I take this rectangle and rotate it around the y-axis, what's going to happen to it? What's it going to look like? It's going to look like a washer. Okay, so we'll take this, rotate it around the y-axis, and we get something that looks like that. So the first thing we need to do before we can start doing the calculus is figure out what's the volume of this washer going to be. Let's start by finding the area of this thing. Okay, so we'll call this a donut if you want, or something like that. We need to find the area of this. The first thing I'm going to do is I'm going to label some things here. I'm going to label 2 radii. This radius I'm going to call big R. This radius I'm going to call little r. I think it's obvious why. If it's not, I'll just tell you the big R is the bigger radius and the little r is the littler radius. Yeah, so the area of that whole thing, the shaded region, is going to be the area of the big circle, which is going to be pi times big R squared, minus the area of the little circle, which is pi times little r squared. Now we can simplify this expression a little bit, particularly because pi is an irrational number and not always easy to work with. We'll just factor that out and only deal with it once. So that area is going to be pi times big R squared minus little r squared. So that's the area of this shaded region here. Using that, how do we find the volume of this? Yeah, so the volume is still the area of the base times the height. So that's going to be pi times big R squared minus little r squared times the height, which this height right here is going to be what? The change in x or the change in y. Actually, in this case, it's going to be the change in y because we were slicing it horizontally, so it would be times delta y. So when we slice it horizontally, we're going to integrate with respect to y. When we slice it vertically, we're going to integrate with respect to x. So when we take a bunch of these washers and we stack them on top of each other, just like before, we can write a Riemann sum. The volume of this whole thing is going to be the sum of the volumes of each individual one. So it's going to be pi times big R squared minus little r squared times delta y. And when we use enough washers, when we let the limit of the number of washers go to infinity, a couple of things happen. This sum turns into an integral. This delta y turns into a differential, a dy. So this is an approximation of the volume of a solid of revolution. The exact volume is going to be pi times the integral from a to b of big R squared minus little r squared with respect to y if we're slicing horizontally around a vertical axis, or with respect to x if we're slicing if we're slicing vertically with respect to a horizontal axis. So we end up with this formula here. In this particular formula, I put dx, and I put the radii in terms of x. So again, we don't have a big R and a little r in our differential, so we can't integrate with respect to those. We have to write them in terms of x or in terms of y. So this washer method, this particular formula, that is around a horizontal axis, so we're slicing vertically. You could just replace all the x's with y's if we're doing around a vertical axis and slicing horizontally.